Thank you for allowing me to go second. I didn't realize that you were so anxious to get started, and so I haven't been on a boat like this for a long time, so I was kind of wandering the halls and exploring, and I came down and realized, oh, they're starting, but I guess you're in a hurry to get this party started, so understand. Arun started with a Oracle legal disclaimer on his first slide, and so I need to let you know that Google has approved these slides, except for this next slide, which shows that despite legal proceedings, that Oracle and Google actually do get along fine together, as long as there's a pretty Viking in between us. So we had a lovely time at Harold's, and I'm sorry to tell you that we had some Vaadin for dinner tonight. And we had a lot more bad Vaadin jokes than that, but I won't repeat them all here. So I want this tonight to be somewhat informal. If you have questions, please feel free to ask them. I only want to talk for about 10 minutes before we start taking questions, because I want to make sure that I'm giving you the presentation that you would like to hear. So what I'd like to do is, this is not actually my agenda. I'm going to skip right ahead to what is normally the very end of my presentation, but I don't know that we would get to it otherwise, on some compiler options for GWT. How to speed up your compiles, how to make your app smaller, things like that. And then we'll come back and look at some introduction and some demos and talk about the roadmap for GWT moving forward, some things that we're going to be working on heading towards Google I/O in May, etc. Did anybody get an I/O ticket here, by the way? Yeah, I'm afraid not. You might not have gone all the way across to San Francisco anyway, but it sold out in about an hour this year, which was completely unexpected. The prior years we had at least several months, and this year 1 hour, actually 59 minutes that I/O sold out. So that means that we're giving away far too many Androids at the conference. Okay. Let me see if I can zoom ahead here to what is normally the end of the presentation, or thereabouts. Oh, I really have just an impossible number of slides to ever do in a normal presentation. Here we go. Yes. So, how many people actually use GWT, including using Vaadin and not knowing that you use GWT? Okay, so that's about half. Now I call it GWT. I think it should be called GWT, but the GWT team calls it GWT, so I call it GWT now too. And I don't like the fact that it sounds like twit, but anyway, it's GWT. So one thing we hear a lot when people start doing heavy-duty work with GWT, and just for those who are completely unfamiliar, it's a Java to JavaScript compiler. That's the essence of it. So we hear that as projects get larger, that the compile time increases. And sometimes a very large project, we've heard of compile times as large as 20 minutes for the final production compile to JavaScript. And people wonder, well, what is that makes the compile take so long? And there's several things to that. But one of them, one tool that you can have to help you with that is the compile report. If you pass this option to the compiler, then you'll get a complete HTML report showing all of the Java packages and the resulting size of the JavaScript for each one. So you can use this to figure out what things you might not need. For example, if you're pulling in 2 different Java libraries when just to do the same thing, when you could rewrite your code a little bit and just use one, you might be able to benefit and shrink it that way. Another thing, to speed up compiles, there is a draft compile option, and this will skip all of the optimization steps that GWT does, and we'll talk about those a bit later. There's also the user agent properties. The GWT compiler tries to be very smart about the browsers, and the GWT team is highly focused on optimizing for user experience, which means we want to create the JavaScript which will run the fastest for each browser. And that's going to be slightly different JavaScript for Netscape and Safari and Chrome and, of course, IE. So when you run a GWT compiler, you're actually creating 5 different versions of JavaScript by default, 1 for each browser. And there's a late binding mechanism when you first fire up your GWT app that it goes and gets the version specific for that browser. So when you're doing development mode, you don't need to compile for all the browsers. You're typically only doing development at some stage in, say, Chrome or Firefox. Hopefully not IE, but you might be doing that too. So you can just set one user agent property in your GWT XML, and then you only incur that compile cost for that version. Another thing that makes compilation expensive is the GWT RPC mechanism. Now I know Vaadin doesn't use GWT RPC directly, but just for your information, if you're using GWT in other ways, RPC supports polymorphism. So if you have a return type or a method parameter in a service call that is an animal, you could get back a cat, a dog, or a Vaadin. And that animal, so what has to happen is that the GWT compiler actually generates custom JavaScript serializers and deserializers for each possible type. So if you pass it an interface type, it's got to do a package scan, find all the types that implement that interface, create custom serializers, deserializers. It adds to the size of your application, and it also adds to the compile time a lot. So we actually recommend that you limit your use of polymorphism in order to speed up compiles. Don't let me fall off the stage. I'm not used to this. Say, hey! Well, it serves me right for eating Rudolph for dinner. So there's a lot of compiler voodoo that you can do in order to shrink your JavaScript with GWT. So I just wanted to toss these up, let you look at them and say, hey, I think I saw something like that once, and then maybe you can go to the GWT FAQ or the GWT Wiki site, which has a lot more information on these. But the first one, -x, disable class metadata. This, kind of like the name sounds, tries to just do the simplest JavaScript implementation and eliminates a lot of the type checking code that would otherwise be there. It will mean that you cannot use some methods like class.getName in your JavaScript code, but it will save space. So this may work for you. It may not, depending on your application. Another thing you can do is this compiler.stack mode. And if you specify the strip option, then it will not generate all of this stack trace info. And we have had projects that have actually seen up to 15% gain just by doing that. Now, when you're in active development, you don't want to turn that on. But your final production compile, you might do that to shrink it. You can shrink your CSS resources if you're using client bundles a little bit. There's a new feature called enum obfuscation. If you're using enum types, the string enum types, it will shrink those to single-digit numerals in place of the string in your JavaScript. And that will work as long as you're not doing any, say, enum.toString operations somewhere in your code. You can get a little bit of benefit there. You can disable cast checking, but you have to be a little careful there. If you actually do have possible class cast exceptions hiding in your code, you won't be alerted to them with this option on. And then there's more in the GWT FAQ, and there is a file called compilerparameters.gwtxml, which is in the GWT source. And that's the file you want to look at if you want to see all the possible options that you can set in the compiler. Whoops. OK, so that's it about shrinking and speeding up our compiles. Now let me backtrack 100 miles here, or 100 slides. And we'll go back to some demo stuff. But this is one of the things that Jonas mentioned at dinner that probably everyone would want to hear. So I thought we better cover it. There's dinner one more time for those who missed it. All right. So what is GWT in 10 seconds? It is Ajax, a tool to help you write Ajax applications, asynchronous Java, and XML++. Why do I say XML++? Because we support 4 different RPC mechanisms, actually, beyond the typical XML HTTP requests that you would make in a pure Ajax application. The benefits of GWT, why people use it, the main reason really is for large teams, it's just untenable to write a large web application in JavaScript. The code becomes unmanageable very quickly. And so you need a strongly typed language that has tool support, IDEs, editors, etc. around it. But there's lots of other benefits to GWT. Your code is browser proof because it supports automatically the idiosyncrasies of JavaScript in all of the major browsers. It doesn't require a plugin like Flash or Silverlight or some of the other technologies. And then you have the issues associated with dynamically typed versus statically typed languages. So can anyone spot, it's a little bit hard to read due to the resolution, but can anybody spot the bug on this slide? I'll give you a hint, it's a spelling mistake. And it's right here. It's misspelled. It says maxi-num instead of maximum. Okay, so if you were writing in JavaScript, you would never catch that, right? You would wonder why your code was not working, but you're not going to get any error. If you use a strongly typed language and an editor, like IDE, then you're going to see the highlight there. That's just a trivial example of the benefit of why you use a strongly typed language instead of JavaScript. Plus, you get all the other IDE tools, the completion, the refactoring, etc. You get the whole Maven universe. Now, a lot of times people ask, who's using GWT? So besides Vaadin, we have a fairly large public company that does a lot with the Google Web Toolkit. And we do eat our own dog food in Google. The AdSense product and the AdWords product, which are our cash cows, of course, are both of those front ends are written in GWT. Also, there's parts of Maps that use it. The folder list on the left side of Google Documents is written in GWT. The new Google Groups interface is written in GWT. And there's actually hundreds of projects that are lesser well known on Google Web Properties that are written in GWT. And why this is important for you as someone who uses GWT is that every day there are tens or hundreds of Googlers working on their various products that find some browser bug, some JavaScript idiosyncrasy, something that affects user experience on the web, and they go fix it in GWT. And we have only one code base for GWT. It is the public code base that's available to you as an open source developer in the SVN repository. So you get the benefit of everything that anyone around the world is doing, but especially all the Google use of GWT. Something we've done a lot of, we focused on in GWT 2.1 was we introduced better integration with Maven. How many people actually use Maven? Okay, quite a few. How many people like Maven? How many people hate Maven? Some of the same hands. Okay, well, the reality is a lot of people are using it, so we needed to provide better support for it, like it or not. It's a little bit challenging because GWT itself is not actually built in Maven. We use custom ant scripts from a long time ago, like a lot of companies. But we have pushed out the artifacts to the Maven Central Repository. We've also improved the integration in Eclipse. So you can now install the M2 Eclipse plugin and M2 Extras from Sonatype. And you can just do file, import existing Maven project, point it to your POM file, and the project comes into Eclipse completely configured. and also completely interoperable with the Google plugin for Eclipse, which was a new thing. It used to be impossible to use those two together, and now it's actually quite possible. You'll notice I see somebody pointing back there, and they might be pointing at this line right here. Is that the line that you're pointing at? No, I guess not. Usually you would just type maven git:"run, but the sample project that we have actually loads data from a text file, and that text file has to be in source main web app, so you have to do this little bit of hackery in order to get it to load properly, but most projects don't need that. So let me just do a quick demo of this example project in Eclipse, and I'm a little bit handicapped here because I'm driving sideways, so bear with me if you would. But here we are in that sample expenses directory, and to launch development mode for Gwt, I can either do it this way, or I could go into Eclipse and say run as web application. Oh yeah, I need that little hat, don't I? You know what, I'm pretty sure I've got this on my line already. So it will fire up the development mode app server, and it will fire up Gwt hosted mode. And this, when you run it this way from Maven, it's going to do what we call the UFM, the out of process hosted mode. So you see the old container window that shows up pre 2.0, and let me drag that over to your screen. Okay, remember this thing or something that looked kind of like it. Let's copy that URL to the clipboard, and then we will move that into Firefox, which I will also drag to your screen, and paste that in. And we'll do our little App Engine sign in here, and it should load our expenses app. This is kind of the canonical Maven app that we're choosing to maintain. We're probably only going to maintain one like this, but this is the one, the expenses sample app. It's in the Gwt source. So if you need, you know, what you need in your POM to make it all work, this is the place to go and check it out. And we keep it updated with each new version. And I'm not sure why development mode is being a little slow to load. There we go. So there's, you see that's the new deck panel that does that sliding action. It looks really good on mobile devices. One of the things that we're really working on this spring is better support for touch events and UI experience on mobile devices. We'll slide our way back here. You know, we have a search, a lot of other standard client-side things. It appears maybe it's a case-sensitive search too. Or maybe just a search that doesn't work. Pretty sure it was up there. Anyway. Okay, so let me talk a little bit about some of the benefits, again, that you get by using Gwt, things you may or may not be aware of. We want it to be a full-stack development environment, so a place where you can develop, debug, optimize, and deploy your code, all within Google plugin for Eclipse, or the Maven infrastructure, because it now works either way. So Google plugin for Eclipse, how many people actually use this? Just a few. So is it not required to use that with Gwt in Vaadin, I guess, or Vaadin? No. Okay. Well, if you're going to do pure Gwt development, you'll definitely want to get this. It is the easiest way to get the latest SDKs because they come in the Eclipse installation process. There's all kinds of wizards for creating new modules and entry points, etc. You get all your quick fixes and code completion helpers. There's JUnit test integration, and then the Maven integration into Eclipse. So something that's new now, also in the Eclipse environment, is Gwt Designer. And with this release of Google Plugin for Eclipse that just went out earlier today, actually maybe it was Friday that GPE went out, 2.2, the GWT Designer now comes bundled with the Google Plugin for Eclipse. And this was part of our acquisition of the instantiations company that made GWT Designer. So you can now do drag and drop screen layout basically in Eclipse with this plugin. And it can support both the Java style of code as well as the UI binder XML template style of code for layouts. It doesn't support all of the cell widget stuff yet, but that's coming. We'll talk about cell widgets in a second. It also has a nice CSS editor built into it, which is one of the few actually available for free for Eclipse. So it's worth keeping around for that. I'm going to cover some of this stuff in my presentation at the conference, so I'm going to skip through a lot of the development mode and things like that. Let me spend a little bit of time on this slide that indicates something a lot of people don't know about GWT. We do perfect caching. So the model here is you put out an application, you have a .js and you have a bunch of images, and then you go to roll out an upgrade to your application. And user comes, they download a new version of your JavaScript, but it references some images which are still cached or some HTML files which are still cached in the browser, and so it doesn't actually get the latest and greatest copies from the server. That's the problem. Maybe even your JavaScript. You've updated your servers on the back end, but clients still have cached your old version of your JavaScript. So how do you solve this problem? Well, the way that GWT solves it is there's one file which doesn't change, the nocache.js, that has headers set on it to tell everybody along the line not to cache it. And this is actually just a tiny bit of JavaScript which identifies the locale and the browser version that's running. And then it goes to the server and makes a request for the real big bundle of JavaScript, which is in an HTML file. That HTML file has one of these cryptic MD5 type names. And anytime you run a new compile of your application, that MD5 is automatically generated, so it actually has a new unique identifier. So automatically, this mechanism means that users will always be getting your latest, greatest code that's been deployed without you having to do any work to worry about rolling updates and caches and all that sort of stuff. It just works for you automatically. Let's see, I'm going to skip through some of this other stuff. Okay, compiler optimization. This is something that I think you might be interested in. Joel, one of our founders of GWT, likes this quote. And the GWT team is very driven towards improving user experience, which means trying to get the fastest, smallest possible JavaScript that can possibly be written to do whatever functionality you're trying to do in the browser. So some of the things that it does are obfuscation, which I'm sure you've seen in the resulting JS that shrinks the code. Modularization and dead code removal. These are very important. GWT does a whole program optimization. It actually follows all of your Java code call hierarchies, and it only compiles to JavaScript the stuff that's actually used. So unlike a lot of other JavaScript libraries, you're not paying for any code that's not part of your application. And this is really neat because it means you can use a lot of third-party libraries even if you only need a small subset of their functionality. Bring them in, compile them. The GWT compiler takes care of removing the stuff that's not used. Method inlining is another optimization. Instead of actually replicating all the call hierarchies in JavaScript, it'll just follow all the way down, find the line of code that actually gets written, and then put that in directly. And then developer-guided code splitting is the run async capability, is a way that you can split up your app into multiple code downloads. So we found internally at Google, some of the teams like the AdWords, they have a lot of tab panels in their admin interface. And because there's a lot of functionality there, at one point it was approaching a megabyte in size of JavaScript that was being created by GWT. They said that's just not acceptable to download a megabyte for your first entry to the page, not even with a loading bar. Right? So what we did was introduce the code splitting capability, and now your initial download is only, say, 100K of the core code that's necessary to generate the home screen. And then as you click on the tabs, it asynchronously loads the additional code behind the scenes. And you specify that by putting run async calls into your code. Okay, so some of the things now that are new in GWT 2.1, and oops, I'm going too fast. And kind of our roadmap for the future. With 2.1, we introduced integration with Spring Roo, and this Spring Roo is for automated code generation, primarily on the back end, but the GWT add-on for Roo will allow you to generate some front-end GWT client code as well that works within the Spring system. There's been a little period where we haven't been actively developing on the GWT Roo plugin ever since we released it. But I can tell you that Spring has hired somebody now, James Tyrell, who was one of the guys who worked on GWT Roo add-on, and he is now full-time on that at Spring, we understand. So there should be a lot more development coming if you're interested in using Roo. Safe HTML wrappers is new functionality in 2.1. If you're using any client-side widgets, you need to know about this. The cross-site scripting attack, there were vulnerabilities possible because there were places in the GWT code, not many, but there were ways that we were allowing you to, say, set enter HTML without properly escaping all the output, so it would be vulnerable to cross-site scripting. And we've cleaned all that up, and we've made it so that you have to explicitly call safe HTML wrappers in order to write code to things like enter HTML. It's a lot safer now and more explicit. Better Maven support, we mentioned that. Request Factory is a new RPC-like mechanism that is built directly on top of JSON. So it's faster compilation time because it no longer has to create all the custom serializers and deserializers. It uses more of a runtime, a reflection-like mechanism to operate. And it's going to be the future of future work with the whole service layer in GWT. But we're not getting rid of GWT RPC, don't worry, except you're not worried anyway because Vaadin has its own. All right, activities and places is to help support some of the model view presenter idea, GWT architecture, and cell widgets. Let me zoom on ahead to cell widgets. This is a really simple idea that's been a long time coming in GWT. Sorry, we have many slides to go through on activities and places and all these other kinds of things. Okay, here we go, cell widgets. So the novelty here is that prior to cell widgets, if you wanted to create a data table in GWT, then you had to populate each cell with a widget and something that extends the widget class. Well, the widget class listens to a lot of events. So there's event processing overhead, which takes up both time and memory in the browser. So we realized we need to make a lighter weight way to do large table rendering. So what we came up with was cell widgets. It implements the flyweight pattern. So each table in a cell table actually only has one widget for each column. And then for each row, the rendering engine asks that one widget to render itself for that row. So in order to do that, it passes it a model object, and we'll show an example of that. And then the cell widget actually reads in the model object and spits out the appropriate HTML. So it's much faster, much lighter weight than having all of these widgets populating your document hierarchy and JavaScript model. We do some data binding now with data providers, which a data provider is just an abstraction that lets you connect either to something local, perhaps just a class in your client application, or there's an async data provider which lets you make calls to the server, and you can use any RPC mechanism to do that. There's scrolling and paging controls, and then with 2.2, which was just released today, we've also added sortable columns and movable column width in the cell table. And then finally, we have new types of input controls which do more client-side validation for type. So we have, besides the old text box, we have an integer box, which is automatically going to check for integer, and a value box, which you can extend with any value type that you want to enforce that type constraint on the client side. So here's an example of a cell widget you can see that a cell table now is parameterized with a model object. So this would be for a contact management application. We have a cell table that's going to render objects of type contact. We have a column, and the column just implements a method to get value, takes a contact, and in this case we're returning the contact's name. So this is to support the flyweight pattern. So for each row, this method is going to get called, and it's going to return the name of that contact. Same thing here for the address. We just add the columns to the table, and that's it. So it's by separating the model clearly, by parameterizing the table in terms of a model object, we're able to do this faster rendering. If you want to make columns editable, there's a new edit text cell, and this will do the standard behavior now. Well, it's become standard where it just looks like plain text, but you click on it and it turns into an edit box automatically. Then you can type a new value and it sends it on to the server typically. You can also create custom column types now for the cell tables. So here's an example of a hyperlink column I created with a hyperlink cell. Actually is doing some boo with request factory to get an ID, send the ID to the server, get back that object, etc. And then you can populate a cell table using a data provider. So here's an example of using an async data provider. We have this on-range change method that gets fired whenever the user, say, scrolls up or down, so that different data comes into view. And you can see here we're making a request factory request, firing it, and then in our onSuccess method, we're updating the data. Calling this is a method on the cell table, I believe, update row data with our response. So it goes and re-renders the table. To do updates with the cell table, you just have to create a field updater class. And so here again, we're making a request with request factory, blah, 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 fire the event. The important line is actually the last one on the screen. This is getting the name column from our cell table and then setting the updater to this above class. If this looks like a lot of classes, like, well, gee, couldn't I just put that in a method instead of having to create a whole class to do this? I would just remind you of an old article on the web called Java is the Kingdom of Nouns. And we like classes in Java, and we especially like in GWT anonymous inner classes. And the alternate title of a lot of my GWT presentations is How I Learned to Love Anonymous Inner Classes, because that's what you do a lot of in GWT. And that's just because of its asynchronous nature. All right, let me check my notes. I think I have a few minutes left. And, Canvas demo. I didn't do that. Let me switch over back to Eclipse. So here's a new feature, brand new, just came out today in GWT 2.2 called the GWT Canvas. One of the things we're doing is, part of supporting the mobile platform is to provide GWT wrapper classes for a lot of your HTML5 capabilities, including the HTML5 canvas, which is just a general drawing object in the browser. So if we run this, you can see some of the power which is now available inside browser. So you can see I can move my mouse around and we get the little balls running around. And that's all being done in the browser in JavaScript using the GWT Canvas. So there's a lot more coming along these lines in GWT. Better support for other HTML5. There's already a project called GWT Mobile WebKit in which they have a GWT wrapper for the browser storage API. The author of that project is actually contributing it to GWT proper. And then there's things like wrappers for the geolocation API and others that are coming. So it's going to become a much better platform for mobile development. And we'd like to think that GWT will become one of the easiest ways to actually write mobile applications that will work across multiple mobile devices, iPhone, Android, etc. So with that, let me ask if there's any questions I can address in the 4 minutes or so that we have remaining, and then I'll be around tonight and at the conference, and please feel free to ask anything. Any burning questions? Yes?
How does the GWT team do testing?
How does the GWT team do testing? On the compiler itself?
More like how do you test that everything looks the same in every browser and stuff like that?
Well, we have a lot of, we have a huge unit test library that's part of GWT itself. As far as browser testing, there's some use of GWT test case for that, but that's really just one specific browser that gets instantiated headless. Really what it comes down to is just kind of smoke testing. Each time we do a release, we have a library of tests. The whole team picks them up and runs through them. If we're introducing a new feature, we always try to go hit all the browsers and make sure that the feature works correctly in the browsers. It's so far it's been good enough. Yeah, you might disagree with that, in which case you probably have issues with your name on it in the issue tracker. Oh, the issue tracker. So let me just make sure that everybody knows about this as well. You probably know about the GWT issue tracker, eh? Yeah, let me fire this up in Chrome here. Oh, it might not come on screen in the time frame that we're looking for. Oh, is the issue working? Yeah, so, well, if you go to the issue tracker, it is a standard Google Code hosting project, so there's a wiki there, and a lot of times new features that we're working on in Trunk are documented on that wiki before ever they appear in any other kind of documentation. So if you're looking for something bleeding edge, make sure you hit the wiki there. Also, of course, the whole source is available there for download. Yeah, that's the main thing I wanted to point out there, is just the wiki is another good source of information. And you know about the GWT group and the GWT contributors group if you really want to see what's going on behind the scenes. Any other questions? Okay, well, thank you very much. I'll be around, but please feel free to contact me. Oh yeah, one more thing.